our research problem and our solution proposed to the research problem and convince the scientific community that our proposed solution is the best solution. So this is the premise on this I have built upon. So these are the broad topics I am hopefully to cover today because many of them are they are in they are in depth and wide in coverage. I tried my best to make it as much simple as possible. So let us move ahead. So I will move on to the basic introduction. The introduction consists of what do we do with statistics and what do we do for modeling. So the statistics is the science of numbers. So once we start collecting the numbers, what will happen is we need to understand underlying theme that what the numbers are conveying. So what will happen is once we collect the numbers for a purpose, uh, they the numbers together as a group will be conveying a theme, but we do not know normally what is that story. So the story builder for the group of numbers is statistics. So this science will help us to understand what is the underlying message that the collected data. That's what we do. So it will help us to uh, uh, plan our study. It will help us to articulate our solution is the best. It will also help us to say what way our solution is better than others. So earlier, if you move back the story 15, 20 years ago, the availability of data is a big challenge. So once the data is available, analyzing is another challenge because you need a computational resource or a computer which has got the highest processing power. Today, all the associated, infra is available, across the world, with a click of a button. So what will happen is, so the infra is available and uh, the data sets are available. The way is we have to set the tone and then, move the direction in the research rather than concentrating on associated things, which were a real challenge some time ago. Today, in the advent of cloud journey, what is happening is even if you need a larger software to analyze the data, even if you need larger CPU clusters, even if you need very high memory, I mean beyond say 128 GB or 256 GB of RAM, they are available on the cloud. So they can be, simply like renting a cab. If we are going out, A, owning a car, B, renting a cab. So what happens is if you own a cab, you have to spend around say large amount of money and then use it for that specific purpose, and the car and model are constant. But if you are not a regular user but you need for a specific purpose, you rent the car, that is cab. So today in the advent of world digitization programs, most of the softwares are moved into cloud. So the cloud is available like a very big supercomputer on rent. You can take it, you can push your data, you can analyze, rent for 1 or 2 hours, and then analyze and then publish your knowledge. That is how simple it is. So having said that, with this introduction, so you can maybe I do not know. This may not have a interactive Q&A, So I will wait for some time towards the end so that we can collectively close the question and answer session. This is what I visualize this. Okay.
Sorry to interrupt you, sir.
Okay.
Yeah, there will be a question and answer session at the last minute, sir,
Yeah.
because if we do in between, definitely you will be having a lack of time to complete your total thing. So I'll ask all the participants to note down whatever the doubts they have and kindly type in chat box at the last 10 minutes after the completion of the technical session by resource person. Thank you, sir. Sorry.
Okay. Thank you. No problem. That's a good thing. Uh, uh, okay. Moving back to the story. So the statistics is an inevitable evil at the end. I will say that we must make use of it, and we must make the best use of it, and articulate our solution is the best. So there are different ways of doing. We will touch on ahead in our story. Now moving on to uh, uh, how we the general scientific world are doing their experiments. So this is the I give you an approximate figure which will show you. It will start with a either physical model or a mathematical model. Here, what I mean to say physical model is you will have a scaled down version of a tangible model, and the tangible model is subjected to all the tests. Then you do scale up. So the example of physical model is if you see the construction of a shipbuilding. So the shipbuilding industry, though engineering drawings and all are available even now, they will build a scaled down version 1 is to million. That means every 1 centimeter on the model corresponds to a million centimeters in the actual physical space. And then they slice the model to extract the internal drawings. So there are a lot of pipelines will be running, and there are a lot of generators and turbines will be installed inside the ship. So they really see in that model the miniature version of these subcomponents of the ship. They place that before they actually go for the physical building to the naval yard, and convince themselves that the what they are building the platform is really going to work for the end user. That is the physical model. Even in our day-to-day life, we would have seen in several exhibitions the buildings scale down versions. The builders will project, how it will look like and all. So it gives us an idea how in the real world scenario the actual end user environment will look like. So that is about the physical model. So mathematical model is we take a problem and then we brainstorm that what is the purpose of the this problem require for a solution, and how the solution is going to impact the society at large, and then move these all the parameters into mathematical domain and run our mathematical analysis and get the results in mathematical domain, convert back into the physical domain. So if you follow this process, what will happen is it is very easy uh, for assessing the problem first, and formulate a solution for the problem, because in mathematical domain you do lot many operations which are not possible in the non-mathematical operations, and come out have a transformation from mathematical domain to the physical world and give our solution. Our simple example is we in our in our schools days, in our school days we would have used logarithms in in our solving our problem. So the real numbers, if you want say 2.7325 like that to 10 decimals, and then multiply with another digit of another 7 8 digits after the decimal, it is tough to do on a regular multiplication. So what do we do for is we will convert into a logarithmic domain, and then instead of multiplying we add, which is a simple operation, and convert back into a real world domain. So what happens is you will get the answer in the domain you want, but the processing is easier. That is one part. Another example is we have seen in our day-to-day world the analog to digital converters. So mostly the people who are touched with electronics or data acquisition areas, they know that most of the world is in analog, but the computer understands in the digital world. So what happens is you have to move the analog information into the digital and do the processing of the digital information or digitized information, and take the answer in the digital domain and move back into the analog domain. This is very well known. So this is what the modeling is for. So you move one domain to the other, carry out your processing, and move back to your intended domain. So this happens in the physical world same way, and in the abstract world, be it a computer world, be it a mathematical world. So we once we develop a model, what happens is we will try to understand what is the behavior of the model, and we try to do certain simulations. Simulation means we assume certain conditions and then say what if that analysis can be carried out. So more example is like the risk analysis in any project. So what if the requirements are delayed? What if the budget is exhausted? What if the tests have failed? All these things, before you start a real project, you can simulate and come out with a risk mitigation plan, be it a contingency plan or be it a mitigation plan. So you can have a risk management plan. So with this small introduction, I would like to move more into the statistical part and some part into the mathematical domain part. Because in today's world, what I believe is mostly we will deal with the random event rather than fixed event. What I mean to say is, if you imagine a model which has got say 1, 2, 3, 4 inputs, and then say one y as an output. So if 1, 2, 3, 4 or the y, or the output is depends on current inputs as well as the past outputs, you can look for a mathematical model. But most of our studies, it is not like that. I mean, excluding some areas in the mechanical engineering, which is noise, vibration, and harsh, those kind of domains, still you can do the mathematical analysis. For example, crash test and all. But in most of the areas, what I have seen is the inputs are randomly varying. So that means they don't depend on past outputs. So what happens is, if you have to simulate a model, you have to depend on statistics, because mathematical model will not answer. So here I am considering statistics parallel to mathematics, though it is a sub branch of or the sub part of whole mathematics. For our convenience today, we are dealing like that. So I have given here a couple of points what way it is relevant to the present world, and then what the statistical analysis will allow us to do. So once what happens is when we take the approach of statistics, so the first thing comes to everybody's mind is, the collection of data. Okay, that's a very big thing. So once you deep dive into that ocean, the data will start frightening us, because data will have the several types of data. So for the audience comfort, what I have done is I have segregated that data, so that we will know what kind of uh, actions that we can take based on the data that is available. So primarily it is divided into two. One is quantitative data and another is qualitative data. And there are still many other subdivisions are there, which the usage is very, very limited and very rarely used. I have not kept it here intentionally, so that we can focus on our study. But whatever I have presented here, this is the very widely used types of data. So I have presented here. So the quantitative data, as the name suggests, it is all filled with numbers. So the numbers are, two types. One is, discrete. The other is continuous. The simple definition for discrete data is fraction doesn't make sense, meaning it is counting. So, so how many defects? So how many defects you will give a number? So there are two defects, three defects, or five defects. I given some example also. So there is nothing like a system having 2.5 defects. It doesn't make sense. So wherever fraction doesn't make sense is discrete. So the converse is wherever fraction makes sense, it is continuous. Meaning what is the speed of the car? Is say 2.5 kilometers per hour. It still makes sense. So that is the continuous data type. So this clear-cut distinction is required, because the every statistical test you plan in the research studies depends on this. So if you use a wrong test, or if you select a wrong test for a data that you captured, be it a discrete or a continuous, the results what it throws out, it will definitely throw out some garbage out, but it will not converge to your thought process. So that's a danger in the statistical field. So you need to be very, very clear what data that you want to collect, and for that data, what tests you need to perform, and for the outcome of test, how do we convert our solution so that our research problem gets completed. Coming back to my slide, so these quantitative data is very widely used during our experimental studies. So we will collect the data, build the model, and then run the model, and then take the output and analyze. But having said that, it is not that only you will deal with the quantitative data. We will also deal with the qualitative data. Qualitative data is also known as attribute data. So what happens if somebody asks, have you satisfied with my service? You will say yes or no. So then there is no number involved, but still we have to do some statistical analysis. So for this, there is a separate branch, which is a qualitative data analysis, and those are categorical variables. So, you will have the ranks. In a class, you will have rank one, rank two, rank three. You will have ordinal scales. The ordinal scale, no mathematical operation is possible. That means you cannot say, rank one plus rank two is equal to rank three. Is not possible. Such kind of operations on ordinal data. On a named data, as I said, is the service is satisfied or not, you will get. Okay. Now the clear question will come, okay, I have decided that my data is either discrete or continuous or a scale data or an ordinal data. So what do I do? So then what happens is you will have several tests. So why you have to do test? That is the first question. You need to test for for several reasons, but I will give you one or two examples. Say you have developed an algorithm, and similar algorithms are developed by some of other scientists in the same field. Previously, they are existing, but there is a challenge. So if you have to say that, okay, I have my own algorithm and there are existing algorithms, so how do I compare my group to that group? So you have two groups, and you have the data data sets that are available. You wanted to say which one is best. So you have to test it. So for that, the best way we say converge on to a specific test. So benefit of us all, I have divided the tests based on which test need to be used where. This is a very very important one. So for example, if you have the same groups and you wanted to say you have taken a data set one. So you have applied your algorithm, and then you have applied the algorithm developed previously by your predecessor. So you have got two results. So how do you know the two results are statistically significant or not? So that you do with the t-test. So if you have say more than two three sets that you have done, you do a test called ANOVA. So these are all required to carry out the test so that we can we can defend our hypothesis. That is the purpose of it. So I have given here, if they are from same group, how do you deal? If they are from separate groups, say the section A in IT department for the mathematics of section B of computer science group, how are they performing under the same teacher or with the same syllabus or with the same um, say survey form. So if you want to analyze, you can do a separate group analysis. Those groups are totally different. Or if you want to test, say for doing online test or face-to-face test or a physical paper and pen test, how section A in IT department is performing. So this is a hypothesis setup, and you collect the data and then test using this. So you will understand your research problem. Okay, online sessions are more useful for this kind of groups. Pen and pencil or pen and paper tests are useful for this kind of studies. So you have set up a hypothesis that the influence of medium of instruction on the students. You have collected the data and you have tested it and concluded it. So this becomes a flow in our logical argument. So in that scenario, I have given you here what statistical tests are is mostly uh, is between reviewers. For example, you have submitted your argument to two reviewers. So say you have your publication consists of 4 5 questions. So two reviewers will have say accept rejected or accept on all the five the points that you have mentioned in the research. So are all the two are statistically agreed or not? You can test using the kappa statistics. So are they completely random or is there any bias in it, and how to do that? So I'm not going into the details of how to do this because that requires a very large amount of time to go through step by step. I just gave you here the glimpse. Maybe sometime later, we can go through, step by step how to do each of the tests, because each of the tests, it has its own nuances, it has its own advantages as well as disadvantages. Some of them I have covered, but let me see, how do I move on. Now, I said, there is again the question will come. Earlier, there is a question that, there are so many data types, which data type I use and where do I use. So now, fine, in our research journey, we somehow convinced that we use a particular data type and then for testing a particular test. So I have given here a structured analysis or a structured way to choose a statistical test. So I have earlier given you here what are all the tests are there. So, and I also given here the types of data. But if they have to marry together, you should have a process. The process is what I mentioned here. So the if the predictor variable is either could be categorical or quantitative, meaning the predictor variable could be a discrete or a continuous, or a discrete or a continuous, or it is a numbered or a non-numbered. I'll put it that way. So for everybody's, to bring on the same page, I have given you an equation here. So when we formulate our research problem into y is f of x1, x2, xn, where these x's are called independent variables or features or columns. Several names are there, or predictors. The y is called dependent variable, output, so on. And these are all different names, but that is y. So these independent variables produce as a combination of y, the output at a particular instance. So different axes, if you have F1, F2, F3, you will have Y1, Y2, Y3, etc. up to Yn. So you will have a table data. That's how the feature table is formed. Now going back to how do I choose a statistical test? So if the predictor variable is categorical or quantitative, that means x1 to xn are either numbered or non-numbered. So what happens is, if it is a categorical, if it is non-numbered, is the outcome variable is categorical or quantitative. That means the y is a non-numbered one or a numbered one. That means if you are doing with a unit test, is the y is a pass or fail kind of thing, or is the y is a number of or the defect rate, some 20 bugs per 20.2 bugs per 1,000 lines of code. That's a continuous data. So if the outcome variable is categorical, then you will choose what is called chi-square test. But if the y is continuous, you will start doing comparison of means. So how many groups are there in that? If it is only two, you do a t-test. If it is more than two, how many such groups are there? If there is only one group, You have ANOVA. If it is more than one, you will have MANOVA, multi-ANOVA, analysis of variance, the full form of ANOVA. So there is one branch we have traversed where the predictor variables are, categorical. But if they are numbered, so what will happen if the outcome variable is categorical? That means the x's are continuous, whereas y is non-continuous. That means you will say, I will have say 5 modules in my software, and say each software has a separate say number of lines of code. So each module has a defect density x1, x2, xn. So will my overall project will pass or fail? So that means y is a categorical. So you use a logistic regression in that case. But y is a quantitative. So y is a number. That means, okay, I have say 5 modules in my software. So what will be the overall impact on the in the program if you want to consider? So you will use how many predictor variables. Say if you have only one, you will have simple linear regression. If you have more than one, you will have multilinear regression. So this structured approach for finalizing a statistical test is mandatory in every problem solving. If we do not do that, what will happen is you will select a wrong test which will give an inadvertent result, and that result will lead our research may derail. So to avoid such kind of pitfalls, especially with the in the domain of statistics, with my little experience, we need this framework thoroughly remember in our mind. And whenever we see the data, we have to see through these eyes and then say, okay, I am formulating these tests, and it makes sense for me that these tests are required, and these outcomes I can interpret. So this is what the purpose of this slide in my in my session. So moving back, what happens is if you see, um, so far we are dealing with a simple cases. That means we have formulated a hypothesis, and that hypothesis we brainstormed, and we jotted down saying that the independent variables x1, x2, xn are required, and there is a linear relationship associated, and that is the assumption, and say we are going to finalize y. So this is one level of complexity. But quite often quite often nowadays, what is happening is it is not that simple. Or or if the independent variables or features or columns in a table, say around say 20 or 30, whatever you can do, most part you can do. But in the advent of with at least 1,000 features, and say some 500 or another 1,000 rows. So, what to do? I mean, yeah, okay. I mean, we will do all data mining techniques or the pre-processing techniques, reduce, come into this. It's one way, and we can do that. But if you want to model it and understand, there is no model which directly fit, because you do not know how y is equal to f of x relation exists. So far what we thought is, we know there is a relationship exists, y is equal to f of x, meaning y is equal to ax plus b is a relationship where a is a constant and then um, c is an error and y is an output. It's a simple. But if we do not even know and we know a set of independent variables, there is a methodology to arrive at a transfer function. So the difference is, as of now, we know the transfer function. That means we know the relationship. But if we don't know the relationship, what should we do? For example, we have say x1, x2, etc. up to xn have got features in a table, and we got a label. So if you have a hypothesis question saying that how the if you are designing a vehicle which is required to withstand a crash, say 100 kilometers per hour, everybody that are going to influence on that. You will have a speed, you will have a BHP, and you will have a, many other parameters which will influence that. But how it will influence? Is the BHP increase the safety or decrease the safety? Is the wheel dia will increase the safety or decrease the safety? We do not know. So for establishing a transfer function or for discovering a transfer function, we have a methodology in statistics called design of experiments. Here, there are two worlds. There is a tangible world and there is an abstract world. Is the things which are physically existing. You have the things where you can touch and feel. The manufacturing world. There is another field which is an abstract field. This is computer science. So this topic of design of experiments is relevant for both the branches of studies. Say, for example, if you are, as I said, developing a car, you need to run experiments in designing the car to meet those specifications. That is one way. Or if you come to abstract world, what must always execute in regression in such a way that no defect is passed through the customer hands. So that is the computer science world. So for that kind of hypothesis, we use a technique called design culture output. It has nothing to do with any scientific outcome. He has made maybe, if I'm not wrong, it's 60 to 70 years ago. And his paper is totally, dedicated for the yield on an agriculture outcome. He has divided the plots into different productive
Sir, your
areas,
voice
and
is
he has
breaking,
studied
sir.
it. And for that, wanted more insights. Coming back to our experiments. Oh, okay.
Sorry for the interruption. Wait for 5 minutes.
Yeah, yeah. I think, am I audible? Uh,
Yes, sir,
um,
you are audible.
oh, thank you. Sorry, I think there is some, I think you have to allow me for hosting also, Prasad.
Sir, you are co-host now. You can share the screen.
Yeah. I am just doing it. Yeah, I think I have left here. Did I finish this? Is my audio is clear while I am explaining this slide? Can somebody say, or do
Yes,
you
sir, it
want?
was clear. The
Okay,
slide was over till
okay,
the ANOVA thing.
okay. Good. Here, what I am mentioning is when we have to do the, when we have to understand the behavior and we do not know the relationship between the independent variable and dependent variable, meaning the relationship between x, number of x's, between the x's and x to y. All these, variants, if we have to understand, we have to conduct the experiments. So conducting the experiment, it will happen in both the worlds, both in manufacturing world as well as computer science world. So if I have to give an example in manufacturing world, what I am mentioning is like the designing of a car. So will the car withstand for a, the crash test when the car is moving at 100 kilometers per hour? That is a research question. Or if you say in my algorithm, which is used for data compression, what features are important and how features are influencing on the outcome? Or if you say, if you are using a data mining in a biology related experiment, so what are the important symptoms or the features of the data are influencing on the why? For example, say you are analyzing a cancer data set, is the patient is malignant or not? Which parameters are directly telling you that these are influencing, which are not? So how do we know a simple linear regression or a multilinear regression cannot do this? Because they have a limitation of say maybe around 15 or 20 axes it can do, but beyond that the regression will not work as easily as we are thinking. So for that, what we have to do is we have to run experiments. So in a physical or a tangible world, you will have experiments. In a computer study area, you will have the test cases. The same experiments in the computer science area, it is called test cases. So what has happened in the good olden words, when you produce your software, the person who has developed will used to do a best case, that okay, these set of test cases are best suited for this module, and then test it. But what happens is it may be best or may not be best, or as we move, it may change. So that is not always our favor. Then what happens is they have moved on to another type of experiments called one factor at a time. One factor at a time means, for example, say you have a three factored experiments. Say you are building a car with say speed, fuel consumption, and say horsepower. Say take these three, or wind speed, four. So when you are taking these four parameters, what happens is you keep constant speed and vary remaining three or vary remaining two and see what is the best performance. So you will have experiment one, experiment two, experiment three, experiment four, like that. Then find out what is the best place for that, for the speed. Then you go for the next parameter. Then you go for the next parameter. parameters. So you get 4 outputs because you have dealt with 4 variables. But what is the optimum of these 4 put together again is a challenge. So one factor at a time started, consuming more time and not giving an optimal, influence of all the parameters, independent parameters on Y. Then people move to this factorial experiments. The factorial experiment means, for example, you have all the factors what I have told: speed, horsepower, and all these parameters have say 2 levels, meaning speed while I'm traveling at 30 kilometers per hour, while I'm traveling at 60 kilometers per hour. So there are 2 levels. So like that, if you see, you will start generating the scenarios for every possible combination. So every possible combination is called an experiment in this. So what will happen is, in the laboratories, they run these experiments physically. If it is a tangible outcome called car, or if it is an abstract world, then they run the test cases. So they will find out what is the optimum parameters that are used for this car to meet the crash specification. So if you open any website, a car manufacturing website, he will give you, say, each car is giving, say, 14 liters per mile, or maybe 20 liters per kilometer under the test conditions. Meaning, what they have done internally is they have conducted several test cases, and for this test case of what are all the parameters of access he is mentioning there, he has got the optimum output. So the meaning of a car fuel consumption is getting 20 kilometers per liter means only when you operate under those conditions you will get. The same way, if you say you have found out an algorithm which will say my algorithm is going to decide the optimal parameters for diagnosing a malignant patient, that means you have found out from the very big data set that those specific axes or the columns or the features are responsible for deciding or detecting a patient is malignant or not. So that is the purpose of this factorial experiment. This factorial experiments in itself is a very big subject in statistical modeling. We will see the move forward how far we can cover into this. So the design of experiment techniques will enable researchers to design simultaneously individual and interactive effects. Meaning, if we have, say, feature 1 to feature 10, it is not only the combined effect of all the feature 1 to feature 10 influencing on the outcome, but how my feature 1 is interacting with feature 2, feature 2 is interacting with feature 3. This is required because when we are doing, regression in the other areas, when we see the fundamental assumptions, what we have is all the features that we are selecting are independent. They don't talk to each other. That is assumption of regression. But how do we know? We will come to know through this design of experiments, understanding whether my factors are or my features are independent or they dependent on each other. If they are dependent on each other, it results a model error called heteroscedasticity, homoscedasticity. These are several errors or the pitfalls in model building. So upfront, what we do is we will know in our experiments itself that our features, what we have collected the data, do they talk to each other or not? That is what I'm writing here. So it will give full insight into the interaction. So if they are interacting with each other, we have to do certain statistical changes to those data so that they don't talk to each other. That is called statistical transformation of the data. You have Johnson transmission, Box-Cox transmission. There are several techniques are there which will make the data independent. So those are techniques that we come across when we have a deep dive into the um, regression model building. It also helps us to understand which features are more important and which features are very trivial in nature, which are very simple and may not have that much impact. But what happens is, especially in a cross domain study, a computer researcher cannot decide what is a prime important feature, what is not prime important feature, just running a statistical test. It may be statistically insignificant because of less volume of data, but if it is a cross-domain product, such as detection of cancers or detection of malignancy types, or say the crash analysis, the computer scientist has to come in contact with the subject matter expert or the domain expert to get it reviewed his validations, because whatever he thinks statistically insignificant in real world, it may not be insignificant. We may still have to consider move ahead in our experiment. So moving on, so because we also wanted to see what is a mathematical model look like. See, so far what we have seen is, we have seen the model, we have seen a transfer function y is equal to f of x. There is an independent variable x and independent variable y, and there is a relationship exists, but x has got a feature of randomly varying, meaning it is not at a given set of time, it will be always like that. On a time domain, it can vary. That is what so far we have seen. But what happens if it is not going to vary, but still we wanted to model the behavior? So what happens is, we'll take the mathematical modeling as an example. So what immediately comes to my mind is the Laplace transformation. So Laplace transformation is a kind of mathematical modeling for understanding stability of a given system. For example, you are designing an operational amplifier or a power amplifier, or you are designing a bridge, you are designing a steel structure. So in all these things, you wanted to see the stability of that. So when the operational amplifier will move from an amplifier characteristics to an oscillator characteristic, that means from stability to unstability, how much time it will take, when it is going to move unstable, or when you construct a bridge, so how long it will take that bridge to move from operational to non-operational. Hello, am I audible?
Yes, sir, you are
Okay,
audible.
thank you. So that what we use a Laplace transformation. So in Laplace transformation, the outcome is a pole zero plot, which should be ideally on the right hand, but it will not remain there as we start doing, as we tuning the amplifier, as we using the physical system, the pole zero start moving on to the right side, and it will one day it will come on the prime axis and will come on to the first or fourth quadrant. The pole and zero are the first and fourth quadrant, which will say that the oscillator, the amplifier will become an oscillator for those voltage and current settings, or the bridge will become collapse if those conditions are there. So that is a physical model. There is no random variation involved. there is no fluctuation involved. It is purely fixed and it will start moving over a span of time with a fixed behavior. For those kind of things, we use mathematical modeling. We do not use statistical modeling. So how we use the mathematical modeling? It is almost same as what we have done in a statistical modeling. But the problem is here we will iteratively refine the model, which we don't do in a statistical model. Meaning we will construct a Laplace transform with one variable and we keep on moving on to multiple variables and then come out with the pole zero plot to understand the stability. That's how the iterative model development happens there, which is different from a statistical modeling. So it is a simple principle here. We will start with a real world problem, often where say, when the amplifier will move into an oscillator mode. It's a very vague. So we'll start there. Then we will start moving, from the electrical domain into the mathematical domain. So we have standard transformation techniques that, if it is a, tangible product, you will have the spring mass, methodology, or move into from electrical thing to the same, start constructing the, models and come out with a pole zero plot as an outcome and study, or Bode plots, which are very famously known as, and understand the stability of the system. So it is widely used, especially in one-shot experiments. For example, if you say satellite firings, it is not that on a daily basis you start fire each and every satellite and understand what is happening. But what you do preferably is you will take one shot and make it happen. So in the majority of areas, you have to make every possible scenario that is realizable on the world before it is being shot, because the cost of failure is very, very high. So use one type of modeling is statistical, the other type is mathematical. So I gave a simple example here. This is a very well-known that, I've given here. A rat is traveling at 20 miles per hour between two cars, where two cars, one car is coming 4 miles per hour and another car is 6 miles per hour, coming in opposite direction. And then what is the total in mile that the dog runs is mostly. So what has happened is we have just collected the given data and we have modeled it, saying that the distance is velocity into time, and then we have hypothesized saying that the v into distance traveled by two velocities. So it has come as 3 miles. If you leave about all the uh, other parts of the problem, what we have done, we have studied the problem here, and we have collected the given data, and then the given data we have moved into a mathematical model, that is here d is equal to v into capital D divided by v1 plus v2. That is the model. So from here on, either you vary the capital V or a capital D, v1 and v2, you are sure to get answer. But what is not there is, you cannot say here the dog may run, may not run, or randomly in between may disappear. Then this model will fail. This model will work where there is no randomization. The model is going to work exactly the way we have articulated in the problem definition. So this is the vast is mathematical modeling for crash tests, which is called finite element analysis. People studying in mechanical engineering will have a very good idea. So in finite element analysis, you will have all the boundary conditions, you will have test conditions, and then you will apply the pressure and then see how much deflection is coming. So for that model, for that computer model, for that boundary conditions, the outcome is constant. It will come. So if you change the boundary conditions, the output is going to change. but the model that you have built, the computer model, is fit for the domain. That means you can use the same for that composite material, whether it is going to work for or not, or for which Young's modulus it is going to work. So that is where a mathematical model is going to work, and it is still available in our practice, in our day-to-day world. Hope I am clear in bringing the distinguish between the subtle difference between the statistical modeling and mathematical model. Moving back here, because I have emphasized on the mathematical modeling in my earlier slide, I am again bringing here to say that in statistical modeling, you will have different types of data, and for each types of data you will have different treatment, and you will have the independence and dependence. There is a lot many things need to be done here, and lot of assumptions will go here, because as I have shown here in the earlier slide, you need to have a proper test in place, proper direction to choose everything. So it is a very tightrope walk. Though statistical modeling looks to be somewhat easier, because there are a lot of softwares available, tools available when compared to mathematical modeling, but the journey is very tightrope. Whenever you make a simple mistake, the whole thing will go into jeopardy, and you may have to start all the way from the beginning. Whereas in the mathematical modeling, even if you make some mistakes here, you can bring back the model into the working state. That is what, that's why I mentioned it side by side here. That is what it is. So in statistical modeling, moving back, as I said in the statistical modeling, so what I said is, you have a lot of models are that are available, because I mentioned earlier here, this is one model. Like this, there are several models. I did not mention it intentionally, because I started with statistical model. So I have parked this mathematical model and then moving back to statistical model. So what is statistical model? Earlier we have seen, we have collected the data, we made some tests, we have understand the test. But what happens is, okay, I mean, we have understood. Now you start collecting more and more data. As I said, after some time, if you want to understand the behavior of the the model, behavior of the data that you have collected, the tests are not suitable for that, because tests will only tell you whether your assumption or your hypothesis is right or wrong, is going to work or not. But if you want to understand the underlying behavior, you have to model it. So that's where either you do mathematical model or the physical or the statistical model. So in statistical model, the widely used one is regression analysis. So there are several other models are there, which I kept it outside because it will take the time may not be sufficient. So I started giving the regression because this is widely used. So in regression, what happens is, it will work in the form of y is equal to f of x. Very simple. But it is not as simple as that. As everybody says. It is similar to, I should say, in software engineering, waterfall model. So the waterfall model, you will have a very easy way to explain. It is you will have RS design, sit AD, and then you deliver it. But it is in the real world, it will not happen. So no customer will accept you to give a requirement baseline. He will ask you to do design. So after design, he will change the specification. So that is the end of the story. So okay, it is very good to learn, at least to give you the basic nuance software development, but it will not helping beyond we have to have our own model. The regression analysis, it's very easy. The simple linear regression, say out total distance from school, say distance from the religious places, and then compute and then say, okay, this is the data I collected, and then compute what is the rent for the next 10 miles. But what happens is if you collect the data for around 10 kilometers and then say, okay, let me predict what will be the rent after 1000 miles or 1000 kilometers, it will not work, because the regression, whatever you do, is a range bound, meaning your access have a capability to vary in a limited fashion. It cannot vary the way you want. So this is what the caution I wanted to tell you before jumping on to the regression analysis. So the regression analysis, as I said earlier, it will work with an outcome dependent variable and independent variable. Okay, it will help you to understand how the independent variables are influencing. That means the direction of influence and the percentage of influence. Meaning, if you have an equation y is equal to 2a plus 2a minus 3b, for example. So, or you say y is equal to 0.2a minus 0.3b. So what happens is A is influencing 20% in positive direction on y, and B is working 30% negative direction on y. Meaning, if you increase y also increase 10%, 20%. If you increase B, y decreases by 30%. So that is the meaning of the regression. So what happens? The regression, as I said, it will work for a range bound, meaning you cannot vary A from 0 to infinity. It is thumb rule in our industry is A can vary by plus or minus 5 to 8%, or B can vary by plus or minus 5 to 8%. Those variations, if you incorporate, you need not have to run the experiment. That is the purpose. Now the next question comes, how many types of regression models are there? I have mentioned here. These are all connected to the data type I mentioned in my earlier slide here. In here, I mentioned the data type. So this is the crux of the entire software statistical modeling. So these data types decides which model that we have to use in statistical modeling, especially in regression analysis. So if the data is continuous type, it is generalized linear model. If it is discrete, if it is Poisson regression, it is a binary data, logistic regression. It is a censored lifetime data. This will use mostly in the reliability studies. It is the proportional odds regression, ordered categorical, again same proportional hazard. Multinomial is log linear, and discrete data is also used mostly things like the prediction of accidents. Because what happens is many areas you cannot create a data set because unless it happens. For example, you wanted to study the accidental patterns of aircrafts or aerospace industry. It is very tough because they are too very strong. You will have very less air accidents. What I am trying to say, the underlying data is very limited. So if you have to design your model based on a very limited data, then the possible regression is Poisson. So with that, what I say is each of these regression models, one second, each of these regression models, what you need to do is you must thoroughly calibrate with the type of data, number one. And for each of the model, everybody has to do two things. You must verify that the proper data is assigned, and you must validate that the model is working. So what happens is verification, I have written it here. That means which data should go where. This is called verification of the model. But validation means, are you sure that the model that you have built is really going to work for the purpose that you have developed? That is the validation. That is the intended use. So the validation of a regression model will come into four subtopics. That means you must be capable of building a histogram of residuals, and you must have a random pattern in the fitted values, and all the residuals should be in the normally distributed. All the errors should be normally distributed. So if you do these two tests, meaning your verification, that means the type of data is correctly connected to the model you're designing, and all the four validation tests are passed, that means whatever you have collected or developed or intended to use is going to work. So the challenge is, if you fail here or if you fail in verification, the model developed for a prediction or a statistical prediction is not likely to give a proper prediction. That is the meaning. So we have to fine tune it, which is a time consuming and a very tough activity till the model gets stabilized. Once the model gets stabilized, you start varying your inputs, it will give you the proper outcomes. So going back, what is that we wanted to achieve is, we wanted to do the modeling for understanding the behavior of our research problem, and the modeling can be done using mathematical domain, logical equations, differential equations, Laplace transforms, or statistics. So when we use mathematical modeling is when there is no randomness of events in the independent variables, we use mathematical modeling. So for that, what we thought is best, I gave you the example of Laplace transform or finite element analysis, which is mostly used in the mechanical engineering domain. And Laplace transform you can use also in electrical engineering or electronics for understanding the study of the systems, or if some people engineering, that is mathematical modeling. So statistical modeling is where you have the randomness associated in the independent variable. That means I know what factors are required for my research. I have done a thorough brainstorming, but what happens? All the independent variables will randomly. That means it may take time. So because of that randomness, I cannot do mathematical modeling. So I move to statistical modeling. There are different techniques associated with that. So we'll have our research problem will come up with several hypotheses. So these hypotheses we will do test to validate our hypothesis. So we have touch based upon several statistical tests, which test has to be used where, and validate our hypothesis. Once our hypothesis is validated, we will start collecting more and more data. Then we will understand what is the underlying behavior by using design of experiments. So the design of experiments will help us to sorry will help us to understand the relationship, that is the transfer function, as well as what is the optimal values of my independent values, so that the dependent value will have a optimal performance. So what are the optimal performance of x's, so that y is optimally performed. So I gave you the example of fuel consumption of a car. So the fuel consumption of the car is maximum at a given condition. He came to know because of this experiment. So, and further, we have touched base upon other types of statistical modeling, which one of the modeling is regression, which is widely used. The regression modeling, we have seen the types of regression models, and each type, is associated with a data type, and each model will give a different outcome. For example, generalized linear model, it will give a continuous data outcome. So it will be a fractions, 1.5, 2.4 like that. But whereas if you see the logistic regression, it will give the probability of the outcome, meaning what is the probability of my module being rejected. So if you have the, say, if you are developing a code in an object-oriented technique, and you have collected the data in the all the related to class and the depth of inheritance, number of methods in the class, all these things you collected, you can compute the probability of the success of the module being accepted. That is the logistic regression. Like that, we'll have separate purpose for each of this we have discussed, and we have understood the behavior of independent variables because we were able to construct a model in both mathematical domain as well as a statistical domain. So with this, I would like to conclude. Hope I have conveyed my best. Now I will open the bridge for the participant to give any questions if I am not confused.
Okay, sir. Really, that was a thankful lecture because you have given a detailed difference between the mathematical model and statistical model, and you have also given the hint that we can do many statistical analysis using the cloud functioning. And Ramana sir, are you available?
Yes, ma'am.
Can you open the chat box for the question and answer section?
Sure, ma'am.
I request all the participants to give whatever the doubts you have to type in the question and answer section chat box. Kindly ask whatever the doubt and whichever the doubt you want to get clarified with the resource person. Kindly chat in the box. So sir has started chatting with everybody. We have almost 35 minutes of time remaining. Yes, sir, we have one question.
Yeah, I
Sir,
yeah,
I'll
F
read
test.
out.
Yeah,
Yeah.
we explain about the F test. So
Yes, sir. They are
when
asking to explain about the
so
F
so
test.
so what happens is when you do not know the yeah, you want t test and F test. Okay, I will put it this way. When you have the when you know the means of the first of all, the underlying assumption is you are thinking that the distribution is normal. Okay, that is taken for granted. So you will use a t-test if you know the means of two data sets. I will give you this way. Um, t-test has two variations, one sample t and two sample t. So one sample T is, say, for example, the class is already performing an average of 70.5 marks, and you want to give a target to the class as 80.5%. Is the target is statistically significant or not? That you do one sample T test. That is for mean. Or if you say you are running a call center and you have two shifts, so number of calls per hour resolved by in the morning and number of calls resolved in the evening, is there a statistical difference? The two sample t test you are all doing on mean, but it is not possible always to know what is the mean. So if you don't know the mean, you will use the F test or the Bartlett test. So if you know the mean, you use t-test. So when you want to say you don't know the mean, so you don't care about mean, you need about only the variance part of it. So when you have to compare the variation, you have to do F. If I am not confused, hope I am clear. You can type it. I think audio is disabled. You can only type it.
Yes, I think they have got the answer because they thanked you for this.
Oh,
And
okay.
yeah, and
May
next
I
question
know
is
what is
from.
the main difference between math? Yeah, I mean, you see, in mathematical modeling, there is no randomness involved. There are no distributions. There are no normal distribution, uniform distribution. All these things are not there. You have a mathematical equation, y is equal to dy by dx. That's it. So dy by dx, it has a rate of change. It don't get confused rate of change with the random variation. So if there is no random variation, statistics will fail because the the basic premise of statistics is you have a randomness involved and you need a direction. So for that you need statistics. If you go to any equation like Laplace transform, there is no randomness involved. So if there is no randomness involved, no statistics can help you. So there you have to jump onto mathematical modeling. Hope I am clear.
Ramana says, a person called Venkat LD, he's raising hand. Can you make him available for this unmuting
One
so
second.
that he can interact?
Sure, ma'am.
He has raised in his hand. Yeah, meanwhile, we will take the next question, sir.
Corona data. And find the results. Yes, I mean, I did not see whatever the data set you are mentioning, but you can do these tests. First of all, find out what kind of data it is, and if the data is, continuous or discrete or categorical or attribute. But be careful. What I am telling is like an exercise, worked out example. It whatever you are seeing, it is like a end of the chapter problem. It's very tough because no data set will be clearly given all ordinal data, all continuous data like that. It will be a mix. So you have to see how to bring it into one side, then you start doing the analysis. That's what a word of caution to you. Yeah, see, network connectivity, it is a challenge not only for you, for me, even my company is also facing. They also say many times, Ramana, we have lost you. And fine, this is the reality of the day. Uh, I am sorry for that. I did my best. But anyway, I'll try to share the, slides. You can go through and reach me, if you have more questions.
Yes, sir, that would be really beneficial for the participants if you can really. Venkat Yaldi, sir, can you hear us? If you want to interact with the resource person, you are free now. Venkat Yaldi, sir. Okay, so meanwhile, there is a question from my side.
Okay.
So basically, I am doing my work on simulation. So
Okay.
for this purpose, I have to do many data analysis for whatever I get output form. So can you suggest one free data analyzer so that I have almost maybe 30,000 data points like that?
No. If you little bit, precise what is the data you have in what form and what you want to do, then definitely I
Such
can.
as measuring the mean square displacements and those things.
Okay. But okay. I mean, immediately come to my mind is Minitab, which I have worked several years on that. So
Okay.
you can use Minitab, do many things using Minitab. And today, for all the universities, correct me if I am wrong, that the cloud platforms are served free of cost. And
Oh,
me. And on every cloud, you have most of the statistical softwares are available. if you are a registered educational institute, that means .edu, university or whatever it is. So they are available free. Number two. Number three, even if you take the cost into consideration, for 100 hours they will charge you 1500 rupees, and that's what I saw, a very big software. So Minitab is the way to go, because I have seen several examples. But if you are going beyond Minitab, as I am telling, you are using something like very big data sets, then I have to think of what is the best one. But normal use Minitab should be good enough.
Definitely, sir. I would try that Minitab. And there is one question from yeah, somebody
There
was
is,
asking about
in
pi
what
test and
way,
t test.
one second, in what way
Pi test.
maths and statistics open the doors to research avenues? Please explain. Oh, this is a very top level question. So the whether it is maths or statistics, it is while you are making your research journey, you will do that. One second. I don't know. Oh, I can't move my. Uh, yeah, if you see here my screen, if you are able to see, so this is the research journey a typical research scholar will do, from identifying topic to this. So while you are going this journey, what happens is you will come across different milestones. In that milestone, you will pick a tool. It could be a mathematical model, it could be a statistical model. I mean, it depends on what you want to do. So but your journey is defined, so you have to move only in this direction. So that tool will help you to progress faster. So you, by chance, if you get a cycle there, you will move a slower pace. But if you get a spacecraft, you will move very fast. So which tool is appropriate, you have to decide, and that will tell you whether it is a mathematical model or a statistical model. Hope I am clear.
Yes, sir. One question is from Venkat, sir. He is asking, are pi test and t test same?
What other than t-test, what is the other one?
Pi test. Pi. Pi.
Uh, I
Pi test.
can he explain what is that pi test means?
Yeah, it's
I do
just
not
about the
know.
last chat.
Oh, okay. And I am
Venkat
sorry,
uses.
I do not get that pi test. Maybe I have not come across. I
Okay.
have to check myself and come back. Uh, you know,
It may.
chi-square test. Chi-square test is when you use on a discrete data. Suppose say you have two systems which has got number of defects. It's a categorical data, number of defects. Yeah, system A. So first television has got 4 defects, second television 3 defects. Like that, you have a defect count. So you will start run a chi-square test to understand which factor is influencing more on pushing the defects in because I largely deal with the defect testing. I gave you that, but chi-square is used for understanding the defect counts. It's for categorical. Yeah, it is for categorical data only. It cannot be used anywhere.
Yes, still more questions are welcomed. Dear participants, you are free to ask questions now. You have been locked since long time. I hope everybody is much clear with your session, sir.
Or maybe otherwise also.
No, sir, because sometimes the main original feeling that comes to in mind that when we say statistical and mathematical, the arts people feel that it is a bit distant away from that. But of course, statistical model is very relevant to arts people also.
Yeah, for example, because you said arts people, for example, if you say psychology, there are a lot of mathematical modelings are there. They don't use statistics. So if you use a model called structural equation modeling, structural equation modeling will tell you where you can never measure with any gauge. For example, I am telling car and other examples. For everything there is a gauge. For speed there is a speed gauge. For material, you have different hardness meters and all. So for statistical, for psychology and other related people, social sciences, suppose you have a hypothesis saying that how poverty is influencing in advancement of education of underprivileged children. There is no measurement. There is no thermometer to say you put it hypothetically it will give you. But they have to do such kind of things are possible to model it using modeling techniques called structural equation modeling, where for example if you say how the loyalty is influencing the quality of teaching in the colleges. So if you see there is no measurement. For example, in the physical world the advantage is most of the things are measurable: temperature, brittleness, strength. You can measure and put it into your data and then go ahead. But if somebody asks you a question, how the parental background or economic background is influencing the academic performance in a corporate college, you cannot measure anything except that putting the numbers of the income. You can't measure in those areas. You have the still mathematical models available, like Bayesian's under Gibbs sampling, or you have, that is if it is statistics. If you have mathematically, you have structural equation modeling, still they are there.
Yes, sir. Meanwhile, we got few more questions. One is from one is from Kotaya, sir. He is asking which test is suitable for time series data.
Yeah, specifically I have avoided speaking about time series data because um, there are several things like ARIMA and the other areas, because I have very less exposure to that. Uh, um, the time series data, it require a lot of pre-processing to do statistical tests. Number one, what is pre-processing is there is what is called seasonal variation in time series. For example, if you are calculating a weekly data, Monday you will have one performance, Tuesday you will have different performance. That seasonality variations you have to remove. Once you remove that seasonality variation, that data will become from a stationary, from a time series perspective, it will become a stationary. Then you have to do the whatever the tests we have done. But having said that, time series in itself is a complicated one, so that's why I have not dealt with it. Any specific question I will answer, but you have the ARIMA models kind of things are available. I am just giving a very top level view. But both the non-linear part as well as time series part, it is a very tough one. You need a lot of pre-processing to bring it to a linear one. That's all I can say as of now.
Yes, sir. One question is from Satish, sir. He is asking what is the test of significance?
Test of significance, it is used in most of the terms as synonymous to t-test. That's what I have seen. Wherever, whenever we do one sample or two sample, most of the researchers papers I have seen, it is statistically significant means they have done t-test or either two sample or one sample based on their articulation. That's what I come across. But not necessarily, because it's a synonym. You would have explained somewhere what is the methodology that he has followed, that significance, then he would have come. So it's a pronoun kind of thing.
The next question may be useful for many of the people here. It will be definitely clarifying our doubts. One question, Venkat Reddy sir, he is asking how the mathematical and statistical models or tools are helpful in languages.
No. Languages means I need a bit elaboration. What do you mean by, is it a computer language or English or
No,
functional
definitely, I
language?
think for language people.
Yeah, that means if somebody is doing research on English.
Yes, sir.
Okay. If somebody is doing research on English, it is useful. I mean, I can give you a generic answer. I do not know. You see, you have the field of ontology, which deals with the languages. So in ontology, there are lots of mathematical models which are used in linear algebra. So there are lot many models are there, and how the language constructs are influencing the feelings, and how by reading the language the feelings can be extracted. That is from an English perspective. From a computer perspective, you will have natural language processing. So both the sides, both mathematical and statistical tools are there. So, but the problem here is we have to baseline with a number. That means because computer at the end of the day, it will understand only the number. We should have a methodology to bring out the English language rigor into number. Once that is done, then everything rest is easy. Yes, they are there. You can refer to a subject called ontology in English. I mean, there are lot many are there. The same ontology concept is brought into the natural language processing of data mining subject.
Okay, yeah. Ramana sir, Sridhar Reddy sir, he is raising the hand. Can you please unmute him?
Which is better, statistics or mathematics? It depends. I mean, but it depends when you brainstorm. If your makes a variation over time or randomness behavior, then you have to choose statistics. If it is a fixed one, as I mentioned, you are articulating in the form of differential equations or difference equations, then you will have Laplace transform, you will have jet transforms, you will have mathematical model. So it is not an option for you in your journey. You will be forced to take that chi-square test or both chi-square test.
X2 test and
Maybe,
chi-square
yeah,
test.
maybe for a symbolic representation, I think some people use this and that. Uh, to my knowledge, it is same. I come across same. It is because what happens is when they write in Word and all, if they don't find that symbol, they do. Uh, Mostly it is yes. Regression explained by statistics, but not mathematics. Why? Yeah, why it is not? There are several other things because the time given to me was only 2 hours, and I was preparing the slide even 10 minutes before Dr. Prasad called me, and the subject given to me is a very fathomless one. I thought it is going give only an introductory one. To be honest with you, there are still each slide part of it has its own length and breadth. So I do not want to justify only one, remaining other parts unjustified. So that's why I have chosen. And most of the research scholars, they use or tend to use statistics over mathematics, because it is very tough to generate a mathematic model, emphasize less. But no way it is inferior to statistical modeling. That's the reason. Hope I am clear.
Yes, sir. Maybe the last question for the session.
Both mathematical and statistical modeling. So if we have time mutually convenient, we can have the internal nitty-gritties of regression modeling, how to construct, how to validate. The how part, it will take a lot of time. Definitely honest with you, 2 hours may not be sufficient because there are several types of regressions. There are several, verification and validation mechanism. If we don't do that, it will predict something garbage. So that's why this is purely a 30,000 feet view or a helicopter view. But definitely, if somebody asks, how do I do a Poisson regression? Definitely, this is not the class. It will give you that, okay, please take care of, there are statistical modeling, there are mathematical modeling, there are some examples here. Please start your journey like this. But every individual case, they have to work out and then go through this pain. Including me, there is no shortcut.
Yeah, Sridhar Reddy sir, you are free to talk now. You have been enabled to talk. If you really want to ask something, you are free. Sridhar Reddy sir. I hope I am audible to you, sir. Sridhar Reddy sir, will you respond? Maybe there is a network issue. I don't understand. Anyway, I take this opportunity to thank you, sir.
Thank you.
And just a minute, let me confirm there are no more questions. Yeah. Okay. Really very thank you, sir, because the topic that you were given was really complex and of course of very broad view. As you said, it is of a helicopter view because it consists of many points. It is data starting from the variables till the analysis of bringing all those variables into single result is really a tough task. And for that, it has a many, such as a plant has how many leaves, and the so many ways we have to analyze data, and it is really difficult to bring all those things under single umbrella, but you have really made this attempt very successful. And it really seems because many participants have get their solution for these doubts. Really thanks a lot, sir, for giving you a valuable time and spending with us. Thanks a lot for this, sir.
Thank you, Dr. Prasad and team for organizing this great event. Of course, we have the teething issues like network and all, but we have to live with this anyway.
Yes, sir.
Thank you, sir. Thank you very much, sir.
Thanks a lot, sir.
Dynamic
Thanks.
problem and a sequence problem.
Yeah,
I think,
last question. Somebody has typed it.
you mean to say the dynamic problem is which varies over a span of time. Sequence problem is okay. If I don't know, nowadays we stopped going to the railway reservation counters. So if you are from a railway department and you have to decide how many optimum number of railway agents are required, so that no customer can wait more than 10 minutes in the queue, that will become a sequence issue. So dynamic issue is, people are, randomly coming and randomly going, but still I am able to serve. So you will have a random issue. So both sides, your modeling is different. You have a queuing theory model, sub model, one way if it is mathematics. Dynamics is anyway, you have whole lots of statistics available. So based on data, you can model it. That's what it immediately came to my mind.
Okay, sir. Really, thanks
Right,
a lot.
madam. Thank
Thanks
you.
to all
Thanks
our
for your
participants
time.
also.
Bye.
Thank you, sir. Thanks a lot. Now, Prasad, sir. Now, Prasad, sir.
Madam.